सह्याद्री वाहिनी, प्रत्येक घरासाठी, घरातल्या प्रत्येकासाठी.
Hello students, myself Pallavi Borade, teacher at Fergusson Junior College, Pune. I teach Vocational Electronics, Paper 1. So in the previous lecture, we have started our first chapter from Paper 1 and the name of the chapter is Instruments. In that lecture, we have seen the introduction to CRO, then detailed explanation of CRT, then we have seen the different types of CRO also, then block diagram of CRO, applications of CRO. So today we are going to start our second instrument, that is the function generator and the digital multimeter. So let's start with the presentation. So from this chapter, we have seen first instrument, that is CRO. So let's start with the second instrument, that is function generator. So basically this instrument is used to generate different types of signals. That's why this instrument is also called as signal generator. So this is very famous instrument in the electronics laboratory. So this function generator has three types of functions we can generate. So let's see the block diagram. So this is the block diagram of function generator. So this one is basic function generator block diagram. So it has three outputs, three types of waveforms we can generate: the sinusoidal waveform, triangular waveform, and square waveform. So if you observe this diagram, there are various blocks which are used in this block diagram. The first block is frequency control network. So this block is basically used to control the frequencies of generated waveforms. Then the output of this control network is connected to two supplies, current supplies, constant current supplies, and second constant current supply, source 2. The output of these supplies are connected to integrator. So basically one capacitor is connected in feedback with this integrator circuit. So this integrator circuit is basically the op-amp integrator. The output of this integrator is triangular waveform. So the output of this integrator is connected to voltage comparator, or you can say the multi-vibrator circuit. So this block generated square waveform. Then the output of this integrator is also connected to resistance diode wave shaping circuit, and this block will generate sinusoidal waveform. So in the final output, we will get three types of waveform, that is sinusoidal waveform, triangular waveform, and square waveform. So let's see the explanation of each block. The first block, that is frequency control network. So externally one resistor is connected to this block. So we can control different frequencies by using this block. So the frequencies which are generated by integrator, comparator, and resistance diode wave shape circuit. So this signal generator is provided with frequency control network, and this will control the frequencies of waveform and regulates two current sources. So basically the output of this control network is connected to the current sources. Second block, that is integrator. So if you observe this diagram, this is basically an op-amp integrator. The output of this integrator is triangular waveform. So for the generation of triangular wave shape, an integrator circuit is used. So the upper current source supplies a constant current, and therefore the output of integrator increases linearly with time. So that's why this upper current source and lower current source are used to supply the constant current for this integrator, and we will get the charging and discharging of capacitor at the output of integrator. That's why this capacitor is connected in feedback with integrator. Third block, that is comparator. Voltage comparator multivibrator is used to change state at a predetermined level on the positive slope of integrator's output voltage. So it will convert your triangular waveform into the square waveform, and it will change the state of predetermined level on the positive slope. So that's why output of integrator is connected to the voltage comparator. that output is compared with the reference voltage of comparator circuit, and we will get the square waveform at the output of this comparator multivibrator circuit. A square waveform is obtained at the output of the multivibrator circuit. Fourth block, that is constant current source. So there are two constant current supplies are used in this function generator. So the direction of the current supply from the lower source is opposite to that of the upper current source. The output voltage decreases linearly with time till a change in state at predetermined level brought by the VCM, that is voltage comparator circuit. So basically these constant current source, upper one and lower one, are used to provide a constant supply for integrator, and it will change the voltage level of integrator output. Fifth block is resistance diode wave shaping circuit. So basically the output of this block is sinusoidal waveform. The output of integrator is connected to this diode shaping circuit, and it will convert the triangular waveform into the sine wave. So that's why this circuit is called as wave shaping circuit. So the triangular waveform is converted into a sine wave by wave shaping circuits. So in this way we will get a triangular waveform, then square waveform and sinusoidal waveform by using this block. So these three types of waveforms are generated by using this function generator, and we can use this waveform for our experiment purpose or practical purpose. And these output waveforms are connected to the output amplifier because we have to set our gain also. That's why these amplifiers are used to amplify the output signal, and it will set the gain of the output. That's why two output amplifiers are used for square waveform and sinusoidal waveform. So applications of function generator. So there are various applications of this instrument. The first is it provides sine, square and triangular waveforms. So you will get three types of waveforms at the same time by using this one instrument. In some types, ramp and pulse waveform are also generated. So these type of waveforms are generated by a spatial function generator. Along with sine, square and triangular, we will get ramp and pulse also. Second application, the frequency range is from 0.01 Hz to several kilohertz. It can be phase locked with second function generator. So if we are using function generator, we will get minimum range of frequency and maximum range of frequency. So you can generate this type of frequencies by using this function generator. Third application, two output signals can be displayed in phases by an adjustable amount. So we can display two outputs by using this type of function generator. That's why this function generator is very useful in our electronics laboratory for practical purpose. Now, next instrument is from this chapter, digital multimeter. So multimeter means we can measure different measurements by using the same instrument. So that instrument is called as multimeter. So there are two types of multimeters which are available, that is analog multimeter and digital multimeter. Then why this instrument is called as digital multimeter? Because the readings which are there, whatever the observation we have taken, those observations are displayed on the screen in the digital form. That's why this meter is called as digital multimeter. In analog multimeter, we cannot measure the readings in the digital form. That's why we have to take manually. Readings by using analog multimeter. So there are some advantages of DMM. The first advantage is numerical readout reduces human reading errors. The readouts which are available in digital form, that's why human reading errors can be reduces. It reduces interpolation errors also. So we can use this digital multimeter to reduce the interpolation errors. It eliminates parallax error. It increases reading speed. Next one is it provides output in digital form suitable for further processing. We can use these outputs which are available in digital for further processing. We can connect this output to computers also. Sixth one is provides high accuracy because the output is in digital form. That's why accuracy is very, very high. Next, automatic range selection and overload indication. So we can choose various ranges and overload indication is also there in the DMM. Next is high resolution. We can use this DMM for high measurements. comparison between AMM and DMM, that is the comparison between analog multimeter and digital multimeter. If you consider the first parameter, input resistance, then in analog multimeter it changes with range, but in digital multimeter it is same for all the ranges. That's why input resistance is very important. Second parameter is loading effect. It exists with analog multimeter. There is some loading effect in analog multimeter and it does not exist in digital multimeter. So that's why there is no loading effect in the digital multimeter. Third parameter, 0 ohm adjustment. So this necessary for each range. If you select analog multimeter, then you have to adjust 0 ohm adjustment for each range, and it is not necessary in digital multimeter. Resistance measurement. Cannot measure high resistance in analog multimeter, but in digital multimeter we can measure up to 20 mega ohm resistance. Accuracy. It is very low in analog multimeter, but it is very high in digital multimeter. Power requirement. Power requirement is more in analog multimeter, but it is considerably less in digital multimeter. Block diagram of DMM. So let's see the block diagram of DMM. So this is the block diagram of DMM. We have various blocks in this diagram. First one is constant current source. Then there are range selection switches are there where we can select different ranges for different measurements. Then these switches are connected to different blocks. The first block is buffer amplifier. Then we have calibrated attenuator. Then we have current to voltage converter and calibrated attenuator. These all blocks output is connected to the analog to digital converter because the output of these blocks are in the form of analog and we have to convert these analog signals into the digital signal. That's why ADC is used, that is analog to digital converter is used, and that ADC is connected to the digital display which is in the form of liquid crystal display. So let's see the function of each block. The first block is DC voltage measurement. So when the input is an AC voltage, it is converted to DC voltage by using rectifier circuit. So here, when we want to measure DC voltage by using this multimeter, we have to first measure AC voltage and it is internally converted to DC voltage by using rectifier circuits. Second one is resistance measurement. So for measuring resistance, a direct current is supplied by ohm source that converts R to an IR voltage drop. So for resistance measurement, we have to use ohm source which will convert resistance to an IR voltage drop. It simply used Ohm's law in this measurement. Second, current measurement. So for current measurement, to measure current, internal low value shunt resistance is provided, a voltage to be measured. So whenever we measure the current, it measures across one shunt resistance which is connected internally in this multimeter. Next is A to D converter, that is analog to digital converter. The input is fed to the A to D converter. It is used to convert the analog signal to digital equivalent which is shown on the LCD display. LCD is liquid crystal display. In DMM, the display is a form of liquid crystal display which will show the digital readouts. Range selection. So when the DC voltage is too high, it is divided down to the range of 200 millivolt. When the DC voltage is too low, it increases by a DC amplifier. So we can select different ranges for each measurement by using this range selection block. Then we have component testing also. By using digital multimeter, we can test different types of component. So if you test the diode and transistor, the meter supplies a fixed current in the forward direction and the voltage across the junction is shown on the display. So by using this block, we can test the component is working or not working. Then when we consider DMM, we have to understand the resolution of DMM. So what is this resolution of DMM? So the number of digit position or number of digit used in a digital determines the resolution. So the resolution is determined the active digit only. So if you consider this diagram here, 2 digit, 3 digit and 4 digit DMM is shown. So in the first part, 1.2 volt is there. Means what? the active digits are 2, that's why the resolution of this DMM is 2. In the second, 3 digits are shown, that's why this resolution of this DMM is 3 digit. And the last part, that is 1.231, then we have 4 digit, that's why the DMM resolution is 4 digit. So these are the active digits which are displayed on the screen, and it will determine the resolution of those DMM. Overranging of DMM. So if you consider this diagram, this is the diagram of DMM. A 3-digit multimeter for 0 to 1 volt range will indicate 0 to 999 millivolt with resolution of 1 millivolt. And a 4-digit is indicating by either 0 or 1, and it is placed to the left of active digit. This allows going above 999 to 1999 to give overlapping between ranges, and this is called overranging. So whenever you select 0 to 1 range, it will indicate only 0 to 999 millivolt with resolution of 1 millivolt. And if your readings is greater than 999 millivolt, it will show 0 or 1 on the left side of your DMM, and it will show the overranging without any active digit. Only 1 is displayed on the screen. So that will indicate the overranging of DMM. So you will understand there is one overrange of your selection. So here we have completed our first chapter, that is instrument. We have studied 3 types of instrument in details: CRO, function generator, and digital multimeter. So let's discuss the HSC board questions which are coming in the exams. So these are the questions I have listed out. So the first question, draw label diagram of cathode ray tube and explain function of each electrode, that is a part in it. It can be asked for 3 marks or 4 marks. If you consider the paper pattern of HSC board exam, then in the electronics paper, we have 3-mark question and 4-mark question in the question A and question B. So it can be asked for 3 mark or 4 mark. So the marking scheme for 3 marks is like 1 mark is assigned for diagram and 2 marks are there for explanation. In the 4 marks, we have 1 mark is assigned for diagram and remaining 3 marks are assigned for the explanation. So whenever diagram is asked in the question, you have to draw the diagram for 1 mark. So draw label diagram of cathode ray tube and explain function of each electrode. So in this question, you have to draw the cathode ray tube, that is CRT diagram, label diagram, and you have to explain each electrode function for 3 marks or 2 marks. And it is asked in March 2003 to October 2017. Next question, explain electrostatic focusing system of CRT. Again, it is asked for 3 marks. So you have to draw electrostatic focusing system diagram for 1 mark, that ray diagram of electrostatic focusing system, and you have to explain the detail of electrostatic focusing system, how electron beam gets focused in this system. Third question, list type of deflection system of CRT and explain any one. So there are 2 types of deflection systems in CRT, that is magnetic and electrostatic system, and you have to explain any one of them for 3 marks. For each type, you have to draw the diagram also. Fourth question, compare electrostatic and electromagnetic type deflection system for 3 marks. So in this question, you have to compare these 2 types of systems for 6 points. So you have to write down the 6 points at least for 3 marks. Next, what is the use of aqueduct coating in CRT? So you have to, in this question, you have to explain the use of aqueduct coating, why aqueduct coating is used in CRT. Next, give function of screen in CRT and explain phosphorescence. So here in this question, you have to write down the function of screen in CRT and you have to write down the definition of phosphorescence. It is asked for 3 marks. Next, write a note on screens for CRT. So in this question, you have to write down the note on screens for CRT, what type of screens are used in CRT. Then you have to explain each and every parameter of the screen: phosphorescence, cathodoluminescence, then fluorescence, persistence, short persistence, and long persistence. So these things you have to explain this in this note for 3 marks. Next question, draw block diagram of CRO and explain function of each block for 4 marks. So 1 mark is assigned for block diagram, and you have to explain those 7 blocks of block diagrams of CRO for remaining 3 marks. Explain the function of delay line and blanking circuit in CRO. So here in this question, you have to explain particular blocks, that is delay line and blanking circuit, for 3 marks. Next question is state any 3 front panel controls of CRO and give use of each control for 3 marks. So here in this question, you can explain any 3 front panel controls of CRO. We have almost 30 front panel controls in our syllabus. So from that front panel controls, you can explain any 3. Next, write function of any 6 front panel controls of CRO, same as 10th question for 3 marks. Next question, explain how a CRO displays a waveform. So in this question, you have to draw first diagram for CRO, and you have to explain how CRO displays a waveform on the screen by using those 2 forces which are applied to horizontal plates and vertical plates. Then what is the time base? Why time base is required in CRO? So in this question, you can explain what is time base signal, the definition of time base signal. Then why time base is required in CRO? That is the necessity of time base. We have discussed in the previous lecture. 14th, that is draw circuit diagram of time base generator and explain its working. It is asked for 4 marks. So you have to draw first circuit diagram. 1 mark is assigned for circuit diagram. So by using UJT relaxation oscillator, that is the circuit of TBG, and you can explain its working in this question. Next question, with the neat circuit diagram, explain the working of sweep generator. Sweep generator is basically a time-based generator. So you can explain again time-based generator in this question. Next question, state any 4 application of CRO, explain any 2. So we have 5 to 6 applications of CRO, like AC measurement, DC measurement, then frequency measurement, time period measurement. So you have to state any 4 applications of CRO, and you can explain any 2 for 4 marks. Next question, explain the use of CRO for AC and DC voltage measurement. So they have given specific application for explanation. So you have to explain AC measurement and DC voltage measurement for 4 marks. Next question, explain the use of CRO for measurement of frequency. Again, they have given the specific frequency measurement for 4 marks. You can explain both methods, that is internal time-based method and Lissajous figure method, in this question. Next question is explain measurement of phase using CRO for 3 marks. Here in this question, you have to explain the phase measurement application. Next question, explain use of CRO to measure phase difference using Lissajous pattern. So the 19th and 20th question is the same. Again, you have to explain the phase measurement by using Lissajous pattern like ellipse or circle for 3 marks. Next question, with the help of block diagram, explain the working of function generator. So right now I have told you the block diagram explanation of function generator. In that question, you can explain different blocks which are used for function generator to generate different waveforms like sinusoidal, triangular and square waveform. Draw block diagram of DMM and describe each block in brief for 4 marks. So first of all, you have to draw the block diagram of DMM and you have to explain each block. Next question, what are the advantages of digital multimeter over analog multimeter for 4 marks? So you have to write down at least 8 points for this question. Advantages of digital multimeter over analog multimeter. So students, we have completed our first chapter from paper 1, that is instrument. So in this lecture, we have seen the block diagram of function generator, then applications of function generator. Then we have studied the block diagram of DMM. In that topic, we have seen the advantages of DMM, then comparison between DMM and AMM, why DMM is better than analog multimeter. Then we have seen the block diagrams of DMM. Then we have seen the applications of DMM. In the last part of the lecture, we have seen the various board questions which are coming in the board exams. We have discussed these board questions and the marking scheme of the board questions. Thank you.